Hello, my name is Burdette, and this is my Physics Lab 1, Constant Velocity. For this experiment, we were tasked with rolling an object in one direction at a constant velocity. Then, we used the app Tracker to record the data of how far it has moved at different times. Our object of choice for this assignment was a water bottle. After this, we created a computational model of the movement of the water bottle using GlowScript. For this model, net force was assumed to be 0 and velocity is constant. Our purpose of this assignment was to explore Newton's second law and the principles of physics. Here's a preview of our results, with the top line being the observed data and the bottom line being the simulated data using the computational model. The first principle of physics we're going to look at is systems versus surroundings. The system is the object you're observing, while the surroundings is everything else. In this case, the water bottle is the system, and the table and literally anything is the surroundings. The next principle of physics we're going to be discussing is Newton's second law, which is on the lines above, and this can be used to derive the velocity update formula, which is seen below it. The last principle of physics that is important for us to understand is the bottom formula, the position update formula, and this is derived from the equation above. Here's the video of our experiment. Next, I'm going to be talking about our GlowScript model, which is used as the computational model of our experiment. Here are the initial conditions used for our model. While we included the mass, it is not necessary since the net force equals 0. The initial position comes from the data found using the tracker at t equals 0. The velocity is only in the x direction since the water bottle only moved in this direction, and this is found from the slope of the trend line of the experimental data. In the while loop for this model, it stops at t equals 1.33 because this is the length of the video. Fnet is equal to 0, and here I use the velocity update formula, which is just equal to the initial velocity since Fnet equals 0. And this velocity is used in the position update formula. In our coding, we had the output being a graph of position versus time and velocity over time, and here is the position versus time graph. Here is the velocity versus time graph, which is a straight line with slope 0 since the velocity is constant. Now I will be comparing the results of the experimental data and the computational data. Here are the results of both sets of data, and the blue line corresponds to the displacement over time for the experimental data, while the orange line corresponds to the computational data. These lines are not the same, and there are many reasons to explain the dissonance, which I will go over soon. Based on logical physics, the experimental data should end up less than the computational data, as the force of friction should cause it to slow down. However, this is not the case. Here are some reasons the data isn't the same nor what it was expected to be. When using Tracker, I was not very precise in tracking the data, as the video was extremely difficult to track. The water bottle was not a good choice of object for the experiment, as it's large and the water inside moving could mess with the movement of the water bottle. While we assume no friction and air resistance in the computational model, they are both present in the actual experiment. If the positive x and negative x directions were flipped, the results would be the same, except everything would be in the negative instead of positive direction. This includes both slope and displacement. It is impossible to say how many forces created zero net force, as it wasn't exactly 0, but rather close to it. For the sake of the experiment, certain forces such as friction and air resistance were ignored. Thank you so much for listening to my Physics Lab 1 presentation.